In the last video, we talked about even functions, and we said that an even function is symmetric across the y-axis. Furthermore, we said that an even function had the algebraic test, which rendered f of x equal to f of negative x. Okay, so even functions, we were pretty satisfied that it was a simple task. You just have to fold it across the y-axis. F of x equals f of negative x. Okay, now let's talk about an odd function. If you're going to be an odd function, okay, you're going to have the following. You're going to have 180 degree rotational symmetry about the origin. So let me demonstrate what that means, okay? Whoops, I can't spell. Sorry about that. Okay, so one of the famous examples of an odd function is y equals x cubed, and I'm gonna demonstrate why this is an odd function. So I've taken the liberty to actually draw this on a Post-it note here, and I'm hoping this demonstration will help you understand, okay? So how do I have 180 degree rotational symmetry about the origin? The way that I do it is if I can pin the function to the origin. So I'm going to pin the function to the origin. And I'm going to rotate the function 180 degrees. So that's a straight line worth of rotation. And you may remember from geometry how to rotate 180 degrees. If I can pin the function to the origin, rotate the function 180 degrees, and it looks exactly the same as when I started, it is an odd function. Okay, so watch the demonstration. I'm gonna rotate 180 degrees. That's 90, that's 180. Okay, you can see that the rotation makes it look exactly the same as when I started. Okay, so that is an odd function. So one more time, I'm gonna pin the function to the origin. I'm gonna rotate it exactly 180 degrees. And that looks exactly the same, therefore it's odd. Okay, now just as a quick note, what's not odd is something that would be shifted up or down or even left or right. So let me give you an example of what is not an odd function. What if I had this, y equals x cubed plus 3? Notice how the function has shifted 3 units up. To test whether this is odd, again, I would pin the function to the origin. So the pinning has to happen at 0, 0, and I would rotate it 180 degrees. Okay, so watch what happens when I do that, right? That is not the same function I started with, right? I started with a function that was all the way up here. After the rotation, it's down here. So this is not odd. I'll show you one more time just so you get the idea. Pin to the origin, right? And then it's not the same. That is not odd, okay? So you may be thinking, okay, great, that's pretty easy to understand, but what's the algebra test? Algebraically, what you're gonna do is decide if f of x plus f of negative x equals 0. And again, I pick numbers like 1, 2, or 3 to keep it simple. I don't ever pick the number 0. So let's do that, right? Here's our function. Let's pick f of 3 plus f of negative 3. And let's see if that adds to 0. Now remember, instead of y, I can call this f of x equals x cubed. So I can substitute x in. So f of 3 is equal to 3 cubed, which is positive 27. F of negative 3, if I substitute negative 3 in the parentheses, that's going to be negative 27. Well, here we go. 27 and negative 27 add to 0. Mathematically, this is an odd function. And these mathematical checks are really, really important and good for when you have a function that looks complicated and you're not really sure. Or if you don't have a graph of a function, sometimes I just go right to the formula because it's not always easy to tell. So just make a note of the algebraic test for even and odd functions, because when you have complicated functions, these are just an easy, quick check. I'm going to pause the video, or I'll have you pause the video real quick and see if you can come up with a function that is both even and odd. So maybe pause the video and see if you can come up with one and then replay it. And I'm going to show you that coming up in a little bit. Okay, so let's see if anybody thought of a function that is both even and odd, okay? So the one that I came up with, and I was only able to come up with one, is I came up with a function y equals 0, okay? So y equals 0 to me seems both even and odd. So how do I know? Well, the first thing is y equals 0 is a horizontal line. It has symmetry across the y-axis. I can fold it across the y-axis and the left side matches up with the right side. So looking at it, it looks even, right? Furthermore, if you were to get, fancy, let's put some points here, right? So let's say this is like 1, 0. Let's say this is -1, 0. I can put it into the test, right? Our test was f of x equals f of negative x, right? So if I put a 1 in for x, f of 1, does that equal f of -1? Yes, because f of 1 is 0, right? When I plug in 1 for x, I get 0. When I plug in -1 for x, I get 0. So algebraically, it's an even function. Now, is it an odd function? Okay, let's check. Remember, to determine if it's an odd function, it has to have 180-degree rotational symmetry about the origin. So let me just pin this to the origin, and we're going to rotate it 180 degrees. So 90, 180, and it looks exactly the same as when I started, right? That has 180-degree rotational symmetry. I'll do it one more time, right? So boom, boom, okay? And furthermore, algebraically, right, if you're going to look at the algebra, is f of x plus f of -x equal to 0? I think so, right? I'm going to plug in a 1, so f of 1 plus f of -1. Does that equal 0? Well, f of 1 is 0, f of -1 is 0, 0 plus 0 equals 0. So interestingly enough, y equals 0 is a really cool function. It's both even and odd, and I challenge you to see if you can come up with more that maybe I have not thought of.